Alright, let's solve the Leetcode problem. So the Leetcode problem is a number of 1319 with 4 divisors. So we are given an integer array nums. We have to return the sum of the divisor of the integers in that array that have exactly 4 divisors. So if there is no such integer in array, we just return the 0. So to go through this, how about we try to understand the problem by trying to check the XML one by one. So given the XML 1, we have a 3 integers number given here, which are 21, 4, and 7. So how do we get the output of 32? So we need to find the each integer numbers in here that could have total divisors of 4. Let's consider we are talking about the, let me try to zoom a little bit. Right, perfect. So let's consider we have a number of 21s. So for the number 21, we could have a 4 divisor. Technically sure, like 1 and the number is a divisor of that number. So frankly speaking, when we are having a number 21, so 1 and 21 is a basic divisor of 2 numbers for them. The another 2 divisors are 3 and 7. So 3 multiplied by 7 is a 21, and 7 multiplied by 3 is a 21. So that is the reason why 3 and 7 are also the divisor of the 21. So if we move forward to the next number, which is 4, so for the number 4, we could have like same with the previous number. So number 1 and then the same number is 1 and 4 is the divisor of the second integer 4. But for the number 4, we could only have another one more divisor, which is 2. So 2 multiplied by 2 is the 4, which become the divisor of the 4. So we have 3 divisors in here. So for the number 7, we could only have a number 1 and 7 is a divisor for the number 7. So we have only 2 divisors. So according to these 3 observations, so the only number that have 4 divisor is 1, 3, 7, 21. So the winners go to the number 21. So what we want for the answer is, we want the answer of the total combination of all the divisors of that 4 numbers. So 21 plus 7 is a 28. 28 plus 3 is a 31. 31 plus 1 becomes the 32. That is how we receive the output of 32. So moving forwards, we have a number 21s in here. Since according to the previous XML, we could reference the 4 divisors in here, which are 137, 21, the output of 32. So 32 multiplied by 2, since we have 2 21, so end output is 64. When we check through the number 1 through 5, which is given in example 3, I'm pretty sure that we're gonna have a 4 divisor, since 1 is only have 1, 2 is a 1 and 2, 3 is 1 and 3 only, 4 is 1, 2, and 4. For 5 is 1 and 5. So we're gonna find any integer with the 4 divisors. So end up the output is 0 in here. I think that is pretty straightforward array. We just need to consider what are the constraints given here. So for the constraint, the number of lunch could be the 1 up to the 10,000 in here. So integer number is the same, 1 to the 100,000 in here. That should be okay for the topic. Okay, that's the array problem. So what I'm gonna use is I'm gonna use a number called total just to keep track of our result, and then I will just simply iteration through, like for nums in nums, we're just going to iteration of the numbers one by one, and then we need to check like what is the base case. So we could have a minimum value of 1, So if, okay, let's try. How about we run through like if, let's check for the possible remainder. Okay, just call R in here. So that could be the square root of the number in here. What do we got? The nums. Let's call num square root. I think in Swift the square root is only allowed the double in here, so we're gonna type caps to the double and then typecast back to the integer, and then we get the remainder in here. So we're gonna check like, so how do we check the square root? So to check the square root, consider that we have a number 25 in here. 25, the square root of the 25 became the 5. So let's consider the square root will become the 5 in here. So if the square root is more than or equal to 2, I'm gonna iterate through like index in 2 to the end of the R. So by checking that, what we could do is, what if the number of remainder divided by our index is equal to 0? So we can keep track of our divisors in here. Let's call like divisor. We have two broach. How about we just use the set? So we could have O of 1 operation. Let's call integer. And then originally let's put f of 1 and num. So 1 is all the divisor of every integer number. I mean like every positive integer. But the good thing is if number is only 1, so that could clean up the number of ones in here. And then if it's not in there, what do we do? So by inserting our possible number divisors with index, and then the divisor divided of the, not the divided, should be the number divided by 2. No, should be the index. Yeah, that's the correct approach, because we still need to keep track of the actual divisors and the original index. And then what do we do is we do have a one break in here. If divisors of count is more than 4, we will break in here, since we don't want the divisors more than 4. So if divisor count is 4, what we're gonna do is we're gonna update the number of total, which is going to be the result in here. I'm gonna just return the total, and we need to do the reduce in here, like as divisor dot reduce, which should be 0 and plus. So that could save the time. Let's check it solved all the problems or not. And let's try to submit. Nice. I think the time complexity will be the O of n into square root of m, because we're using the square root in here. But for this space complexity, that will be the O of 1, since we don't use any extra mode in here. Yep, that's pretty much for it, and let's see you in the next one. Bye.